Are we all good? Oh, excellent. We have audio. Okay, well, hello everyone. Thanks for coming. My name is Paul Elliott, and I work for Codasip on safety and security systems. I was formerly at a company called Cybersecurity Labs, and we were acquired by Codasip just a few months ago, and we're now well and truly embedded and working hard to deliver Ron Black's message from his keynote speech this morning to deliver safety and security solutions to the RISC-V space and to RISC-V systems. So we have been working on a dual core Lockstep subsystem, and we thought that was a good candidate to present to you because it covers both the safety and the security aspects. And so we've taken the Codasip L31 core. The L31 is a 32-bit RISC-V with a 3-stage pipeline. It's quite a good seller. And we put 2 of those cores together inside our subsystem. And the 2 are operating, running the same software in Lockstep, but having an offset between the 2 cores. And the offset can be fixed, or the offset can be randomly jittered, which is useful in security applications like smart cards. It's quite a common thing to do inside a smart card. So we support both models with that. We could have architectural diversity by mixing 2 different cores as well, if that was a requirement. We have here an FPGA board, and it's a Xilinx Zinc 7 board, and so the dual core Lockstep design is mapped onto that fabric. And it's running navigation software and talking to the laptop, which is running a graphics demo. So it's obviously quite a dry subject. What does a dual Lockstep system do? Well, it detects errors. How do you demo that? So we thought we'd do an interesting demo for you guys. And so one of our guys sitting at the back, Carl, has come up with this. Thank you, Carl. What we're trying to depict here is a kind of futuristic factory with lots of worker droids roaming around. So if I, first of all, select the single core version, so this is a single L31 running navigation software, and these are our worker droids roaming around. And this is Henry. Henry's a maintenance droid, and Henry's navigation software, unfortunately for Henry, is running on the single L31 core. And we've mocked up some hardware to inject faults into the load store unit of one of the CPUs, and because they're constantly being checked in the dual Lockstep configuration, the error will be picked up, but in the single core version it will cause a data corruption. So we'll see what happens. So if we inject a fault here, you see Henry starts to panic. He hasn't had a collision yet. Oh, there you go. And we've basically killed Henry straight away. So what normally happens is his health deteriorates and goes down on this meter on the side. Let's try again. Okay. And so we get some. We'll try and get some accumulated damage. Oh. And this is going to take a bit longer. And when he hits the walls, it causes damage as well. Okay, and he's caught fire, and then we have game over. Okay, so we can now come back, and we can switch modes. So we're now running the dual CPU configuration with the continuous checking between the 2. And let's try running that one. Okay, now I'm going to hit the fault button. Right, fault detected. So as you would expect in a dual core system with checking. And that's the demo. That's the most interesting we can make it for you guys. It is quite a dry subject, but I hope you enjoyed it, and I'm happy to take any questions. So in this particular configuration, we're monitoring the instruction fetches and the load store accesses to the main memory system and comparing the 2. Okay, so we're looking, so it's prototype stage at the moment, but we're looking at qualifying this for ASIL-B. But we think it could be used in an ASIL-D system, but ASIL-D requires an analysis of all the entire system, the context around the CPU, so the end customer would have to be involved in doing that, but we're certainly looking to get ASIL-B on this. No, this is, it's only 2 cores, so all we can ever do is detect a fault. We are looking at doing a triple voting system as well, which will be in the future. And I should also add that this is kind of tightly coupled to the CPU, this mechanism. So when we connect to a cache memory, for example, we need to protect the cache memory or the entire memory system. So we're looking at adding tags to the memory. So for example, you can implement something like a Hamming code. In some of the security specs, we've seen CRC8 used quite a bit. So that will get extended out into the memory system. Okay, I guess there's no more questions. Thanks everyone for your time. Thank you.